Hi everyone. All right. Hi everyone. Are you able to hear me clearly? Hi Alvin, April, George, Kar, Manu, Ravi, Shamit, Hang, Rahila, Sunesh, Tamika, Tegu, Srini, Sudhakar, Sunny. All right. So welcome to the session, and today we are going to discuss Hive, NoSQL, and Headspace. All right. So there's a question. There's a question from Sudhakar. Is the file created under warehouse one of the replicas of data node? Is the file created under warehouse? So warehouse is in HDFS. Okay. Warehouse is in HDFS, and everything that is created on HDFS goes to data nodes. And every file that's created would have the blocks, and those blocks would be replicated. Okay. So warehouse gets replicated on by default into 3. Okay. So you can take a look at checking the replicas the way we did using HDFS admin. Okay. So there was HDFS FSCK command which we used. So you can use the same command to know how many replicas are there. All right. All right. So a question. Okay. So the way it happens is the directory structure in HDFS is actually from the point of view of HDFS. Let's strictly talk about HDFS. Forget about Hive for time being. Anything that's created in HDFS, the directory structure specifically and the file name is actually metadata, and it's in the name node. Okay, so name node knows the folder names and all the file names, and each file which is there in this folder structure is broken into blocks, and those blocks are replicated and kept on data nodes. All right, did I make sense to you, Sudhakar? All right, so the warehouse is nothing but just another directory in HDFS. A question from Alvin. Okay, let me just make the window bigger, and that should be a good idea. All right, there are quite a few very interesting questions. I would love to answer those questions now. All right. First question is from Elvin. If source tables are populated with new data, would it be a healthy practice to do insert overwrite of Hive tables on frequently basis? If source tables populated with new data, would it be healthy practice to insert override of Hive tables on frequently basis, or is there an automated means of doing this? For this, we generally use a command called scoop. We generally use a command called scoop, and there we could always say that do an incremental copy. While doing the incremental copy, we could use an identifier, or we could do the incremental copying based on a date time field. All right. So those are the facilities provided by Scoop. All right. So Scoop basically does this for us and does this in order. Specifically, Scoop is great if your input data that you're trying to copy into HDFS is really huge. Manu's question is, load command is used only for external table? No. Use command, use command is used for internal as well as external tables. Okay. Generally, we don't use load command for external tables because we define the location while creating the table, right? So because in case of external tables, the data is already there somewhere, and we are just pointing to that location using our create table construct. Okay. Uh, Follow-up question from Kar is, this is only for internal tables? So yes, I think you're right. So internal tables, we generally need to do the loading of data, but Hive does not deny if you try to load data into internal tables, external tables as well. Okay. A question from Srini, is there a way to know where are the other replicas? So you can actually use the command called hdfs fsck, the command that we used in the beginning of the session to show you where are those blocks. Okay, so you could give the file name and it'll show you the machine name and the IDs of the replica blocks. Okay, a question from Manu. While creating table, can we mention number of replicas? I'm not sure, but there should be some option. So basically, Manu's question is that while we are creating table, right, under the hood, there is a folder that's empty folder that's getting created in warehouse. Can we mark number of replicas on this folder? I'm not sure. Okay, but you can always use a command, hdfs command to set the number of replicas. Okay, after you have created the table. Question from Sunny, can I ask you two questions from Peg? Yes, please go ahead. Okay, second question from Alvin is, if the structure of the source table gets changed, new columns etc, how would we know other than normal company communication? Okay, would alter table be the only means to update Hive table? Yes, very good question, Alvin. Okay, okay. A question from Alvin, let me try to answer this. If the structure of source table, so the objective what Alvin is talking about is, let us say we have certain data in our classic databases. Okay, is that the case you're talking about, or is there any other source? Source is, let's say, in a classic databases, right? Any MySQL, Oracle, or somewhere. And in those cases, in those cases, let us say the data is frequently getting updated in the MySQL or Oracle, and we want to push this data continuously into our Hive, right? So we talked about that we could use Scoop for this. Now, further question is, what if the structure of source table gets changed? What would we do in those scenarios? If the structure in source table is changed, as of now, there is no single mechanism to do that. There's no single mechanism to basically capture that, right? Let's say there's one new columns are getting added in the source tables. There would not be an automated mechanism in Scoop. Scoop, let's say we are using Scoop. There is no mechanism to quickly capture a particular error because of new columns. Okay, because while we are copying data from using Scoop, we are basically copying certain section of the data. All right. One and therefore the table once gets created, we just keep on adding new rows. Okay. So this is something that would be basically based on the normal company communication. People need to inform each other that, hey, we have changed the table. Can you also update your target table in the Hive using alter table statement? This is how it would be done because Scoop does not detect that change. Yes, yes, because Scoop will not detect the new addition of the columns. Though it might give an error in case you remove certain columns. All right. Question from Nitesh. How do we create tables in Hive for unstructured data? Okay, interesting question. So I will show you the tweets that we talk about in the case of Twitter. We can load those, or let's take a case of doing the, let's say there is an unstructured data. Let me try to answer question from Nitesh. It's a very important question that how do we create tables in Hive for unstructured data? Imagine that your company is keeping the unstructured logs of web server in certain folder. And what you want to do is you want to process those logs using Hive. Now, now, first thing that you'll do is you will create a table with a single column, and that column's data type would be string. Okay? We are assuming this case where there is a plain text file, and the whole line we are putting it in a single column. So first table that will create would be this. The create would be this table with a single column, right? And then after running the processing on this table with single column, such as running a regular expression, selecting A0, comma B0, and so on, by splitting the data, by splitting the data, by flattening, splitting, and so on, by by doing that, we would be able to convert this single column into many columns. Okay, and then we can parse that data to form other tables which are which are which are in a well format. Okay, this is how I would do the unstructured data with Hive. Okay, did it make sense to you, Nitesh? Wonderful, wonderful. So, question from Kar. Generally, create external table is used under what circumstances internal tables are created? So, okay, I'll explain to that. So, in generally, we use external table. Why? Because we use Hive to process existing data. Okay, and when we create internal table, when we have internal table and we put data into internal table, and at any point if we delete this table, the whole data will get deleted from HDFS. That's why we generally avoid internal tables. If you want your data to be dropped when the table gets deleted, you should use internal tables. Otherwise, prefer external tables over internal tables. All right. If you want your data to be dropped when table is deleted, use internal tables. Okay. A question from Sunny is regarding pig. I have a data set where the data format is 10.02.2017. I'm not able to work with date time data type. It is not a proper date format. Okay, so I would suggest you a very cool thing. In case of pig, there is something called a regular expression, regex split. Okay, so input data format you can break down into that, and then using those columns you can do a projection and then convert it into a proper date. Okay, if you want, I can have a one-on-one discussion with you. Just send me 2 different time slots or 3 different time slots, and then I'll connect with you. All right. So you can generally go with regular expressions in case you have the data formatting issues. You can extract values out of a string or split the data based on regular expression. All right. Sunny's second question is, when I execute the below command, it gives a warning. Project equals for each ny data, meaning we are iterating through this data. Generate $0, which means we want to print out the 0th column as stock. Okay. Comma, substring $1, comma 0, comma 1 as subname. Okay, and $5 minus $6 as today's diff, and so on, right? So it says that encountered, so base operator plan encountered warning using overloaded function one time. This is okay. This is okay. Whenever there is a kind of typecasting that happens, you generally get warning in case of pig. This is just to let you know that it will try to do the typecasting, or it will try to guess the data type. Okay, so you can ignore this warning completely. All right, good, good, good. Yep. So how do we delete tables in Hive? You can simply say drop table and your table name, but remember to select the correct database, okay, by saying use space database name. All right, so you can say drop table, my table, whatever is your table name. All right, wonderful. Great set of questions. All right, so should we move on? All right, so yesterday we talked about Hive, and we talked about what is internal table, external table, how to load data. We could either just simply copy the data into the folder, or we could use the load command to load the data, and then we can execute select queries. And then we talked about partitions, and afterwards we talked about views. Then we talked about how to load JSON data. All you have to do is add the jar which is required and then select the row format accordingly. Now, let's talk about one feature called order by. Although it's just another query construct, in case of MySQL, order by is something out of the box, right? Or in case of any traditional database, order by is straightforward. Now, in case of Hive also, the default order by is okay. The the default order by is good enough, and it guarantees the global ordering. Hive does this by pushing all data through one reducer. It does it by pushing all the data through just one reducer. Okay, meaning it has a single reducer under the hood. Remember that any query that we write in Hive gets converted into, so any query that we write in Hive gets executed as MR, MapReduce, okay, on Hadoop. So, so same is the case with order by construct. It gets converted into MapReduce. And when it's converting MapReduce, the number of reducers it selects is just one. Okay. Remember, when we have multiple reducers, we have multiple output files, and then there was the issue of merging. That's why by default, order by just uses one reducer. Okay. And this is unacceptable on large data. You might end up just one use output, one use bottleneck on the reducer side. Then Hive came up with a construct called sort by X, which means you can specify that use reducers, okay, use reducers based on a particular column. And the way reducers are selected is based on gigabytes of data. Per 1 gigabyte, it creates one reducer. If you have the data in 10 gigabyte, there'll be 10 reducers. The problem with this is the way when we were doing word count. You remember the way we were doing word count? Okay. We were doing word count. The result of first reducer could have been Aaron and Bain, and the result of reducer 2 could be Adam and Barbara. Although both the results are mutually overlapping, right? If you see, both of these results that you see are individually sorted. Aaron comes before Bain, as well as Adam comes before Barbara. Now, these are the two results by two reducers. To merge these two results, again, you will have to do some other operation. And that's why problem with sort by X is it generates data, it generates the ordering, but the output would be very awkward because it'll first display the result of first reducer and then second reducer. So after using sort by, you will get Aaron Bain and then Adam Barbara. Therefore, therefore, sort by is not sufficient, right? Sort by is not sufficient. And there and hence Hive comes up with something called distribute by X. Okay, similar thing as what we discussed as partitioning. We create a partitioner in case of MapReduce such that Aaron and Adam goes to first reducer and the result of first reducer is Aaron and Adam, while while Bain and Barbara comes out of reducer number 2. Therefore, concatenating the two is easier so that the overlapping range does not occur, and hence concatenating is far more easier. So that's why if you combine sort by defines the sort by says that there will be multiple reducer, and distribute by says that it would ensure that the data is first partitioned by a particular column, okay, particular value. Therefore, there will be proper ordering and multiple reducers. So when we say distribute by say name, so what would happen is reducer 1 will get Adam and Aaron, and reducer 2 will get Barbara and Bain. And therefore Hive came up with a syntax which combines both distribute by X and sort by X, and it is called cluster by. So whenever you want to cluster whenever you want an ordering on a particular column, you will have to use cluster by a particular column. The downside of using cluster by is if you want to distribute the data based on some other criteria and sort data by another criteria, then cluster by may not be your solution. All right. So in very simple words, cluster by a particular column is basically a scalable version of order by. If you are churning humongous data, prefer to use cluster by instead of order by. Okay, do I make sense to you? So we have order by, distribute by, sort by, and cluster by. Sort by defines the key for the mapper, okay, and distribute by defines the basis on which partitioning would happen. Partitioning as in deciding which key would go on which reducer. Cluster by combines both the things into both these things into a single construct. All right. There is another idea called bucketing. Okay. We could also divide our data into multiple buckets. All right. Multiple buckets using cluster by, same construct as cluster by. This cluster by is not part of select query. This cluster by is part of Hive itself. Okay, is basically clustering data by default into multiple buckets. Somebody was saying earlier that is there indexing on the table. This is kind of indexing. This is sort of indexing on data. All right. Now, the new concept with Hive is ORC file. ORC is optimized row columnar file format. Just like RC file, okay, where there was, you remember the sequence file format, right? Sequence file format was great for merging multiple files together so that you can process multiple smaller files using MapReduce. Similarly, a lot of NoSQLs as well as Hive has come up with these columnar file format. Okay, we will discuss columnar file format later, but for now, it basically provides a highly efficient way to store Hive data. It improves performance when you are reading as well as writing or processing your data. So it has a built-in index, it has a min and max value and other aggregation part of the format functions, and it supports it supports large-scale deployment and has been proven on it. Facebook uses ORC file format for 300 plus petabyte data. So how do you create table in the form of ORC? Okay, you can say create table name, file name, and then you define the fields. The important part is stored as ORC. Okay, this is the important part, stored as ORC. Then once you have done that, now you can keep on adding data into ORC table value and so on. All right. So I'll be very honest with you. Hive guys are saying that they have been trying to push ORC. They are trying to say that it has been proven very well, but still, industry is little skeptic. Okay. So I mean, the adoption is going on right now, so to ORC files, so that people can modify data in Hive as well. All right, they're trying to provide a NoSQL server out of Hive. All right, but again, it's great for Hive is great for when you don't have many highly available requirement for modifying the data. Okay, in those cases Hive is great. All right. So you can take a look at ORC in more detail. So ORC file makes it possible to modify data in Hive. We can say, we just like with MySQL or Oracle, we could create table and insert columns and values into it. Okay, and then process it. Data under the hood, instead of being saved as plain text file, as in our case, it will be saved in a binary format called ORC. All right, everyone with me so far? If you want to give it a try, we can give it a try. Okay, so I'm going to copy paste this part into the window. All right, wonderful. Let's give it a try. All right, so you can see that it has added data into this. I can keep on adding more values into it. All right, so question is from Hang is, can we access the ORC outside the outside of Hue's Hive? Um, we can access from Hive console. We can access this table from Hive web service, I mean Hive server, and we can access directly from HDFS. Let's take a look at describe ORC underscore table. Okay, and I'll say describe formatted. Okay, so the data is saved in this folder. You can see the data is saved in this folder. Let's try to open it. So let me just try to open it. So here is the format. You can see that there are some data here. Okay, so this is a binary format. You can see it's a binary format. It's not a plain text format. Okay, so this table, this folder represents the data of the table. All right. So what error are you getting, George? Now this ORC file you can copy, and there are the libraries. Even with the pig, there is a library with which you can access ORC file. Okay, while you saying load data using pig, in that you can specify the data format and it can load the data from ORC file. Tamika says that the table exists, which I did not create. Maybe you have not selected your database correctly. In my case, the database is selected here. Okay. In your case, in case you're not able to select from drop down, before executing any of these statements, you can say use your database name. Okay. By default, you might be getting error because you might be using default. Okay. Default database. Maybe you are here, like here. Okay, so here there should be ORC table already. You can see there is already an ORC table created by somebody. So select your own database using use command, and then you will be able to execute this. Or Just rename your table name by putting, this is the table name that we are creating. You can put your name along with this, say George or underscore Tamika. And similarly, here you'll have to change the name here as well. Okay, wonderful. All right. So that was that's how. All right. Just give me a second. All right. Are you able to hear now? Okay. There's something wrong with these headphones. They somehow go out of focus, and I have to take it out and plug it in. All right. Sorry for that. Now, question from Sudhakar is: will update delete statement work on ORC? Yes, they will work only on ORC file. Update delete statement do not work in case of non-ORC data. The reason being that a Hive, the way it has been designed, is basically for querying data, but recently they have started supporting adding or deleting records. Okay, what is the syntax for update? Yeah, so the general syntax for update is you can say update table set x set column 1 equals to some value where, okay, where column 2 equals some value. Okay, so this kind of statement sets the column 1's value to something uh, where uh, where you have this kind of data. Like for example, if I say, let me just try with you because I have not yet tried. Okay, so we were talking about ORC table, right? Let's say we want to change the last name of John. Update, what is the table name? ORC underscore table, set last name equals Giri, just for the heck of it, where first name equal John. Okay, Attempt to update or delete on a table this that does not use ACID output format or is not bucketed. Okay, so looks like ORC table also need to be either bucketed or there has to be a construct here saying it is ACID output format. But syntax is correct. This is how it's generally done. Okay, probably we'll have to add some more uh, characteristics of a table here. Right? So the syntax is like this. All right. As I said, the update and delete are still not in the production ready kind of a model, and we do not expect that from Hive anyway. Okay. Question from Mohsin. How data is stored in ORC such that it supports insert? It basically, the way they are doing is they are storing data in the form of ORC, and ORC uses paddings such that when you insert a record, the data is added into the space left earlier instead of creating a new file. All right. So that's how we will talk about this kind of model while we talk about HBase. A similar model is used by HBase to support insert update on a massive scale. All right. Okay. Okay. A question from Kar. When we execute data modification statement, what happens to the original file? So those files are generally either deleted or recreated. But the kind of formats, these new formats like ORC, they leave space in the end of the records to keep for the new records, okay, and so on. All right, that these are the reason why ORC file has been ORC kind of model has come up, so that the append-only data for append-only file systems like HDFS could support update and insert. Okay. I think that answers Sudhakar's question as well. Question from Hang. You might have explained this already, but what is value underscore temp underscore table? Honestly, I don't know because this is something which I'm noticing today. This is something I'm also noticing today. All right, this is something I'm also noticing today. I don't know where it has come from. I have no clue actually. Ah, I see. So you can see that for every, when I inserted value here, this is what happened. See? So when I did insert statement, it actually has created these tables. All right. So probably, let's say I say hung here. Let me see. Interesting. So these are the temporary table that are being created in order when we are inserting values into the table. Okay. Yeah, these are not getting deleted. That's awkward for me. All right. We don't need to commit this. We don't need to commit this because we did not start a transaction. So generally we don't need to commit. Maybe they'll get dropped after a while or so. Or maybe they'll be there, just that we'll have to delete these by ourselves. I'll have to take a look at it, right? So, all right. So, all right. Coming back to Sunny's question, Sahida's question, what are the real-time use cases of ORC? ORC is basically used in the cases when you want to insert records manually or delete records. When you want to do the database kind of operations, you generally go with ORC. Okay, you have humongous data, but you want to modify that data slightly in the database itself and do the querying later on. So in those cases, you could use ORC file format. I see. Maybe you'll have to configure in Hive. Okay. All right. Good. I think you are right, RS. It might be for row level locking. Yes. Sure. Let me try to execute the. All right. Wait, this does not have the newer one. It does not have the newer records. All right. It's kind of taking time. All right. Are you able to hear me clearly? Yeah. Yes. Go ahead, Sunny. Question from Sahida. Can you repeat the bucketed concept? Okay. So we talked about bucketing here in here. So bucketing is nothing but breaking down table in under the hood. Hive will try to break down data into multiple buckets. Okay, so that to improve the performance of the query. This is similar to what we have in indexes. This is similar to indexes. All right. Okay. Thank you, Sunny. So looks like our concurrency is true, bucketing is true, non-strict is true, and so on. Okay. How is it different from partitioning? In case of partitioning, we were manually keeping multiple files and then mapping that to the column values, right? Here, Hive is trying to bucket our data into multiple files. It is more similar to how should I say? This is more similar to more similar to saying saying that we are defining 32 mappers. Okay, 32 mappers. That's what it means. All right. When we say external tables, can table of any format, DBMS, MongoDB, or so yes. So based on kind of what kind of Saturday serializer, deserializer class we have, we can load data from the formats like MongoDB or EBS. Okay. So you can, yeah, you can load that. All right. You can connect to Hive using Tableau. Tableau is a visualization tool. It allows instantaneous insight by transforming data into visually appealing, interactive visualizations, and it calls it dashboard. So you can try this out when you have time. So you can download Tableau on your desktop, and then uh, you will have to install Hortonworks ODBC driver for Apache Hive for your operating system. Okay, and from Hortonworks downloads, and then okay, then you can visualize top 10 stocks with highest opening price on 31st 2009. Okay, so basically you can query the data using Tableau. Okay, so I'll share a separate hands-on that we have made for this that would be useful to you. All right, this one which we have made, and I'll be sharing this with you. All right, a quick assignment. Another assignment. One assignment is connecting to Tableau. This small video I'll be sharing with you. Second is this one. Okay, so you have, let's say you have downloaded data from download data from this place, this movie lens place, then unzip it, start Hive command. Okay, now create Hive table here like this. Okay, and then load data local. Notice the local part. This is for when you are trying to load data from local file system, meaning the console from where you're running the console into Hive directly. Okay, if you're doing the same thing from the hue, then you don't have to load data from local. Instead, you will have to first copy this data into HDFS and then load data from HDFS. Okay, and once you are done with that, you can query the data using this query. Okay, yes. All right, so you can try these two assignment, and this should be good enough. All right, I'm going to give it to you, this part. It is also available in the slides that have been shared with you. All right, all right. So further, you will have to find out for each movie how many users have voted for it. For movies having more than 30 ratings, what is the average rating? So first assignment is use Tableau to visualize data. I'll be sending the video to you regarding this. And then second assignment is using Hive, query movie lens data. All right. Okay. In case you get stuck, this one you submit over by sending an email to support@NoBigData. And You basically submit, in case of this, you have to submit your answers to these two questions. Okay, submit answers to these two questions. All right, so that was our discussion on Hive. Okay, I have copy pasted this one, Srini. Sunny, it's up to you. If you're interested in doing pig assignment, please go ahead. Okay. And the same thing you can actually do using Hive as well. Pig assignments are available in No Big Data LMS. In the pig session, you will see subjective questions. You could take a look at that. All right. So these are questions based on the previous table that we are creating. So first, you create your table. Okay. Then download your data. Then after downloading the data, you can directly upload it into the folder that you're creating for this table. Or if you're using the console, you could use load data local like this and so on. All right. All right. So that was our discussion on Hive. Okay. Srini is not able to connect via web console. Let me try to see if, okay, so I'm going to CloudX Lab, my lab. It's same as what we have in there. Now, so basically this console is having little issues to connect because it does not support more than around 8 connections simultaneously. That's why it takes sometimes forever to connect. It waits till somebody releases a connection. And that's why we prefer to use Hue instead of Hive command. You can download on your laptop this data and then upload it here into the folder. Okay. I think it won't. Yeah. So Srini, you are the lucky one. You have been able to connect because I'm not those. Because this thing actually works only for 8 simultaneous connections. So we have been trying to create multiple Hive servers and okay. So if out of the class, if you are trying maybe after the class, it should work because there are chances that other people are not using it. All right. That's why I prefer this Hive editor. Okay. Okay, Sunny. So you may be the culprit because of it. All right. So never mind. Yeah. So all right. Now we are able to we have been able to understand the Hive so far. Let's continue our discussion on something really, really important. Okay. This discussion that we're going to do is about NoSQL. NoSQL represents Okay, NoSQL represents not only SQL or no SQL as in there is no structured the traditional databases. Okay, so let's start our discussion on NoSQL. It's going to be interesting. Before I go ahead, there's a question. What is Hive Server 2? Hive Server 2 is basically the, okay, so I think that is something I forgot to tell you. So, all right. So where is the architecture diagram? Right. So the Hive does not only have a command line interface or does not only have a web interface. There is also a thrift server that's running. So what is a server? Something that's running continuously, and you can make a call to this server and get your queries executed. So this server is called Hive server. Okay, and this is the second version of it. So that's why it's called Hive server 2. Using Hive server 2, you can actually talk to Hive as if it's a relational database. As if it's a relational database. So from your Tableau system or from your BERT system, which is business intelligence and reporting system, or any other system, you can actually talk to Hive via Hive server as if Hive is a classic database that supports select queries. Okay, as if it's a classic web server that supports SQL queries. It's a classic. So Hive server 2 is that. All right. Did it make sense to you, Kar? So this part that you see here, I think I can draw a shape here like this. This part, this part is Hive server 2. Okay. This part is Hive server 2. Okay, so this server is basically, again, the way we were connected to Hive from the console, and we were connected to Hive via Hue interface from the web interface, right? So in the similar way, we can connect to Hive via from the outside server, say from your desktop, from elsewhere. This server runs on a port called 10,000. Okay, so you can connect to this port, and that should basically, okay, so you can connect to this Hive server at port 10,000 and then give queries, and internally it'll call driver and then make the call here. Okay, yes, in Tableau we will be connecting to Hive server 2. All right, or even Microsoft Excel, one of the assignments that we will give in future, we will be using the Hive server 2 via Excel. Excel will be running on your desktop. So I think instead of Excel, we are going ahead with Tableau. I'll be sending you the video. Good question. What address should we use when connecting for your environment? Okay, so I'll tell you. So this, so if you go to Hive, you have Hive server. So we have created a load balanced version of Hive server. There are two Hive servers running. So you can connect to this machine. Okay. The IP address is this, or if you want to know exact the domain name, I'll give you the domain name. So this is 154, right? 13.154. Let me just tell you the user-friendly name for it from the lab credentials or IP mappings actually. So this is the machine. So so if you are connecting to from Tableau, so you have to install Tableau, then you have to install the Hot&Works driver, and then for connecting, you have to provide c.cloudxlab.com and your login and password. These login and password you'll have to provide, and it will start showing you your databases. Or you can also mention the database name, just like in a classic database. Okay, and then it would show you your tables, and then you can write your queries, and it'll give the results, and then you can drag and drop those results and display on dashboard. Okay. All right. So, okay, a question from Sudhakar. JSON, which was not covered yesterday. We talked about JSON briefly. So we talked about something called, okay. So if you have your data in JSON format, so Tableau will be, Tableau video will be sending you, um, we will be sending it to you, Samit. Okay. Or I'll be uploading into LMS and informing you. All right. All right. So, okay. Not here. Where was my JSON data? Yeah. So coming back to it, Sudhakar, I think we talked about what is JSON format, right? Okay. So let me also, actually, I think I would do is I will show you the entire flow. This you can try it out, and this you can try it out, and it should be good. All right. Let me just talk about it. All right. All right. So I think this is a better assignment than any other assignment. So let's just Okay, so you can try this project, or you can finish this project before the other assignments. Okay, and here's the problem statement for you. Problem statement is this is the project which we were trying to accomplish as part of one of the after a couple of sessions, but I think this is good enough to go now. So please pay attention. So you have to follow these steps and complete the project. You can go ahead and choose deviations. More the deviation, better it is. And you just have to justify your deviations. So the problem statement for this assessment, this project is to do sentiment analysis. Here we are going to do sentiment analysis for Iron Man movie. The objective of the exercise is to do the sentiment analysis based on the tweets data, which is downloaded from the Twitter. Okay, you can also download the data yourself from the Twitter. Okay, and then follow the entire process. But for this exercise, we have already downloaded data here. Okay, the steps below outline a primitive strategy for sentiment analysis of the movie Iron Man using Hive. Okay, it is up to you whether you choose exactly the same steps or you use a different strategy. So there are quite a few variations possible here. For example, you could use Pig or Spark instead of Hive, or you could use different algorithm to compute the sentiment based on natural language processing. You could use your own Flume pipeline to download data. So these are the various possibilities of variations, or you could come up with your own ideas. All right. So I'm going to outline a very basic strategy to do the sentiment analysis from Twitter. Okay. So first of all, log into Hue, which is here. Okay, locate the data which is located in sentiment data slash sentiment files, again sentiment files, then upload slash data. Okay, let's take a look. So we go into file browser, then here if you change this location or simply click on this, you will get to this folder. This is where we have kept the data. It contains two folders, data and SQL. So this data folder has three files in it. One is tweets data. This is your tweets raw data. It is compressed in gzip format. Okay, and Hive will be able to handle it easily. So this is one tweet from here till here. This is one single tweet. Okay, in this tweet we have all the characteristics, all the metadata around the tweet. Okay, the main tweet is here. Main tweet is this. It says somebody has said Iron Man 3 crushes opening day records in China. Okay, so and here is some link and so on, right? And it has here. So it has all the details like time zone, which language is it, what is the icon of the user, what is the handle of the user, and so on. It contains all the details about the tweet. Okay, so we have the data that contains tweets raw, and then we have another data set which is a tab separated one. The previous one was JSON formatted. This one is tab separated. Okay, and here this file contains the 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 time zone versus country, meaning we can infer the country from the time zone definition in the tweets. Okay. Then third table we have is dictionary. Dictionary is very important. Again, this is tab separated. So you can always say that my data fields are separated by tab while loading this in Hive. So you can see that here, this word is negative. This word is negative, while this word is also negative, while above average, you see, is a positive word. Similarly, above is a positive word. Okay, so we are going to use this dictionary to convert each word in the tweet into plus or minus one, and then sum up everything to check if the tweet is negative or positive. Okay, so you have to submit this. The timeline is mentioned here. Okay, timeline is mentioned here. So project start date, project end date is basically last is 26th March. Although you can start the project from today itself. Okay, so this start date is not really any significant. Earlier, we used to give this project when the session finishes in Hive, and therefore the time is there. So here we have been given three data sets: dictionary, time zone to country map, and then tweets. This folder contains all the tweets in a compressed JSON format. Yeah. So Alvin, yes, you can collaborate in teams. Definitely, I would love that thing. So all of you can basically communicate to each other. I have shared emails in one of the email having all the list, or you can use Facebook students group to communicate and form the teams. I would love to have you do this in teams, but the team formation you will have to do it by yourself. Okay. Okay. So this uh, right. So this document is residing in here. You can see. All right. And the the presentation here, the presentation is here. Although this is a little older presentation, we will be adding the new one because new one has been updated yesterday only. Okay. And all right, Sunny. Okay. So Sunny's email ID is also mentioned in the email. So you can carry on the discussion over the emails, and you can, you know, form the teams. Yeah, so that's a little challenge. Sometimes we don't have the Facebook accounts. In those cases, it becomes a little tricky. Okay, a question from Srini. Where can I find the recording session? Is that what you mean? So generally, I upload it here. Yeah, so generally I upload it here session-wise. So you can see that yesterday's session was uploaded here. Okay, today's session will be available here. All right. So, okay. So once you're done with that, you have located data. We have gone through the data, this data. Follow the example query. Okay. Let's take a look at the query. The query is available in this folder. The query is available in this folder, which is here. Okay. Uh, is it? Yesterday's video is blurred? Ouch. Let me take a look at it. I have the raw video as well, and I'll take a look at it. Thank you for letting me know. Okay. So now in this query, please pay attention. First of all, copy this start your Hive, okay? Start your Hive server. Also, this statement, you can simply say add jar and you don't need this statement, okay? And then you have to copy the data to your own home folder, okay? In HDFS, you could say. So the sentiment files you can copy to your home folder, and then you can run these commands in Hive. One is uh, turn off the reserved keywords, and second is add jar. Add jar, you can directly point to this location, okay? HDFS colon, so something like this, okay? Uh, so you could actually either copy it to local and then try to add jar, or you could directly add jar HDFS colon slash slash and the URL name. Then you create your own database, right? And then use that database. Then here's the important part. Rest you can take care. This query, please pay attention to it. We are saying create external table, tweets raw, and we are defining all the fields. We're defining all the fields of this table, okay? And then we are saying that the row format is JSON Survey. This is the class. This is the program that'll be used to convert JSON into the table, right? And we are saying that ignore the malformed JSON. So these are extra attributes that we are providing. And then this is the location of the data, right? You remember that we have copied it to our home folder, so you have to insert here your username here and then execute it. Once we are ready with tweets raw, then we will load the dictionary. Also note that we are creating external tables. We're creating external tables, and we'll create external table for time zone. And once we have created time zone table as well as dictionary and tweets, then is the time to start processing. Here we are extracting user ID, timestamp, the tweet text, and so on. And then we are creating another view on top of another view. This is a view. Okay, this is a view, and then there is another view on top of the previous view, and then another view on top of this particular tweets clean, and so on. And after that, we are saying that join the data with the dictionary, join the data with the dictionary, and that's it. Okay. All right. So once you have joined with the dictionary, here we are saying if negative is found in the dictionary side, make it -1. If positive is there, basically replacing the string negative with -1, positive with 1. Remember, in the dictionary, we had negative and positive words, this string instead of 0 and 1. And you can basically, here we are basically joining a dictionary with the L2. L2 is the cleaned up data here. And once we have, for each word, once we have computed whether it's -1 or 1, then we create another table and and sum up all the tweets in each all the words in each tweet. Here we are grouping by tweet ID. Okay, here we are grouping by tweet ID, and then basically we are saying sum up all the polarities of each word in each tweet. Okay, and if that polarity is greater than 0, total of each word's polarity we computed here, -1, +1 or something, and then we sum up all the polarities for each tweet, and if that sum is greater than 0, we say that a particular message in the tweet is positive, or is negative if the total of the word's polarity, each individual words, the total of each word's polarity is negative, then we say negative. And then this table contains information, and we can join it together and represent it like this. So tweets BI is our final word, final table containing details about each tweets, whether it's negative and positive. Now, you can represent this tweets BI using Tableau as mentioned in the previous exercise, okay? Or you could follow this document and install Hortonworks driver and use Excel. And notice that here we are using c.cloudxlab and providing our login password, and the port number is 10,000. All right. So you can see these are the details that we provide. We have to provide while configuring the driver, and then whether it's Excel or whether it's Tableau, we can query this table from there. Okay, so go through this document and you should be able to complete this project. Okay, now this is the primitive approach that we have suggested. You could do your own variation. If you are doing more variation, then it'll be better. Okay, all right. So is everybody with me? So you have to do three things basically. So you will have to the finish this one. You remember the exercise which we talked about? Not this one. Um, this one. Okay. This is the Hive subjective question. Okay. Then the sentiment project. Okay. This is the sentiment project. So one is this, that you have to finish the movie lens question. Then second is the project. Okay. And third, we will share the video and tell you what to do over the email. Okay. Third one will be the visualization of data using Tableau. I'll be sending the video for that. All right. But finish these two assignments. Okay. That'll give you a very good control over Hive. All right. So that's pretty much what we wanted to talk about Hive. Yes, Alvin, you should be get everything that you need from these source files: tweets raw, time zone map, and dictionary. Okay, and one more thing is this JSON survey that we talk about that contains the JSON library for parsing the raw data. Okay, converting representing JSON data as a table in Hive, we might require this serializer, deserializer, okay, that we have mentioned in the project. All right, all right. I hope that that answers your question as well. The regarding the JSON parsing, Sudhakar. All right, so let's start our discussion on NoSQL after the break. We will talk about that occur after a while. Okay. The reason, there is a reason, not today, Ravi. We will start Spark next weekend. All right. This project does not have to be submitted right away. You can submit the project as defined in the LMS. And that should be good. All right. So before we, so let's take a break for 10 minutes. and back by 9:40 p.m. IST. Okay. Hi everyone, I'm back. So should we start now? All right. So a common question is, till what date will the lab access be there? 90 days from the day we started, which means 14th of April. Okay. So 14th of April, I have actually set the end date for everybody in the session. In case you face any problem, like has your lab access has expired, just let me know. Okay. Yes. Yes, Sunny. D3JS is interesting. Oh, Tamika, did that work? Oh, great, great, wonderful. All right. So, okay. So, there was, okay. Yes, D3JS is interesting and is widely used in this data science for presenting complex data. So it's a nice library, and a W is also used often. Just please note that we hardly ever present big data to the user. Okay, so there is no separate big data visualization tool. There are usual data visualization tools. Why? Because we hardly ever present big data to the end user. Instead, instead we make our data we create the insights on top of data, and those insights should be something that can be presented and the human eye should be able to um, uh, judge it or appreciate it. That's why we generally convert a humongous data into insights which are smaller in nature and then use the presentation tool. Earlier in the usual database scenario, what we used to do is we used to let the data churning to the visualization tool itself. Visualization tool will query our database and will do the churning whenever there is a presentation request. But in case of big data, we generally process data separately, and then that data gets presented by our visualization tool. All right, great. So let's start with NoSQL session, should we? All right. Sunny's point is that is there any discount on extending CloudX Lab? I'll let you know. I'll send an email. I'm actually trying to do that with CloudX Lab, that we should be able to give discount to our students or something like that. We could have a referral kind of a discount that you just refer your friend and you can have 1 month of CloudX Lab free. So that's a kind of, we are building that. Okay. So till that point of time, we'll just have to wait. So by the time the session ends and your uh, CloudX Lab access expire, you should have discounts. Okay. So okay. Where are the questions we are supposed to answer in Sentiment Lab? I have copy pasted the link as well as it's available in the LMS. Yes, it's called subjective questions. All right. Here. Sorry, I think I sent it to only Kar. Okay. Question from George: how and when will be placed in groups? So the idea is that you drop in. So there was an email I had sent you where there were email IDs of everyone. So if you want, I can again send the email address. So I'll do one thing as a note to myself. One is W video. Okay. The other is send project grouping emails. Okay. Project group email. Okay, so I'll just send you a bulk email to all the people putting in the CC saying that you guys can go ahead and create the group and you all can reply to the same email and yeah. All right. So you can start the quiz here. Okay. So here is the question, you see. The answer you have to write is the query. Okay, Tamika? So here we are saying that this is the approach and then you can start the quiz and then you can answer the question. Good? All right. So in the text box, you have to put your SQL query. That's it. Wonderful, wonderful. So can we start now? All right. So welcome to the NoSQL session. Today we are going to talk about NoSQL. Let us say you had a cart, okay, or we have a cart, and we need to carry more load than a single horse can carry. Right now it is having a single horse, okay? So what would we do? What is it that all we can do? There are two things. There are two things. One, we can replace the horse with an elephant and carry huge load. This is called vertical scaling or scaling up, okay? Scaling vertically up. And the second mechanism or second strategy is horizontal scaling. That is adding more horses into the same cart. That's called scaling out or horizontal scaling. Our work will basically revolve around horizontal scaling. Classically, I mean, traditionally, we have been doing vertical scaling. Why? Because vertical scaling was easier. We did not have to change our cart. Okay, meaning, let me talk in technology terms. When our servers become it becomes impossible to process data using our servers, we generally add huge hardware. We add, let's say, 4 cores, and we put really fast hard drives and so on. So that way we used to survive a little bit. That used to be vertical scaling, and this is the common way in the industry that we vertical scale everything. Okay. Similarly, I'm going to talk about a case study here. Okay, and this case study is the common scenario, and I have seen this happening multiple times in my career. Okay, well, first thing I observed at DE Shaw, and this was very something that struck me. At DE Shaw, we basically had exactly same scenario. On the initial public launch, we moved the data and the application from local workstation to shared, remotely hosted MySQL instance with a perfectly well-defined schema. This is the day zero where everything looks great. Okay, this is the I mean, this is the day when we are launching. You have the perfectly well-defined schema in the database. Then the service becomes more popular. There are too many reads hitting the database because you did the PR, your service became popular, people started using your service, and then you suddenly realize that every time there's a query, we are making a query. Every time there's a request from the end user from their browsers, we're making a query in the database. So very simple to solve such kind of problem. Just add a caching layer on our web server. What is a caching layer? There are systems like memcache. Memcache is memcache keeps the data. Memcache keeps data in the memory pre-prepared so that you don't have to query the database, assemble everything, and give it to the user. So most common things that are static in nature, we generally create a memcached layer for those. We pre-prepare the data. Now, the most important part to understand is the moment we have the moment we have caching layer. The moment we have caching layer, what happens is the data becomes non-acid in nature, meaning the caching layer is basically a design which inherently is inconsistent. Meaning, let us say a user has modified data, but another user is still getting the results from cache because there is always a time gap between the cache refresh and the data modification. And therefore, the moment you bring in the caching, the system is no longer strictly acid in nature. What is acid? Quickly, anybody? Acid are the four properties ACID of the databases. A for atomicity, C for consistency, I for isolation, and D for durability. These are the four properties of classic database, which are really kind of really the rules to live by when designing standard databases. So every SQL database have these four property transactions. Okay, all the transaction in the standard database have these four properties. All right. Atomicity means every transaction either gets committed or not committed. There is no middle way. Consistency means all the users see the same data at the same time. Isolation means if there are two people modifying, their changes are isolated from each other. They don't mingle with each other. Durability means any change that we do is saved, persisted, it doesn't get washed away. So as the service becomes popular and there are too many reads, you had the problem of hitting the database too much. So it is a very simple thing, and probably all the web application designer would actually quickly do this step as soon as it occurs. Okay. Now, if your system is really popular, if you have built a very useful service, it would grow in popularity further. And at this point, too many writes would start hitting the database. Okay, so no problem. We had a solution for this. It's basically do a vertical scaling up of the hardware by the fastest server available, say 16 cores, 120 GB RAM, and really fast hard drives of 15,000 RPM. So this only few were able to afford. Why? Because this kind of cost is hard for a small company. And therefore, a lot of startups actually died at this phase. I remember companies actually dying at this phase. Why? Because the service started becoming popular, and when it became popular, the server could not handle, and it actually kind of jammed. No request got answered, and effectively they lost credibility, and people did not again open their websites. I have seen this happening with many companies. So at this point, the if they are not able to acquire this kind of hardware, they will die. But those who are able to acquire, they would be happy for some time until they hire let's say you got VC fund, you hired all kinds of people, they all kinds of product managers, they added more and more features into your product, and the query became complex. So imagine this: at Amazon detail page, the page that I was owning at Amazon, we were having around around 200 features. The detail page from which user makes the buying decision. That page has an image on the left side, the title, then there is a author button, as in author label, meaning who is selling this, and then there is a buy now button, and there are these detail bullets, and there are hundreds of features, close to 200 to be precise. There are reviews and everything. So as your product becomes more and more popular, more and more features start coming in. And the normal way of creating these features is you create separate table for them so that you do not hurt each other's feature. Okay, so as more and more tables come into play, when you are serving to the user, when you are rendering a page, you will be making too many joins, and when you make too many joins, the query becomes complex. At this point, one of the things that you would find strange is we denormalize data. What does it mean by denormalization? In denormalizing means instead of referring the IDs of various things, primary and foreign keys, creating foreign keys and referring things by foreign keys, we merge data into a single table. Let it repeat. Okay, so denormalization is something that a DBA will never digest. And I mean, when I joined the show, I learned the normalization first 6 months, that okay, this is how we normalize our database. Those were my initial days of career, and we were I learned to design the perfect database and all of that, and write the perfect query, understood what does it mean by acid and how does it matter, and all the transactions and everything. But the moment we faced load, when the moment we started reconciling billions of records, we realized that our tables are inefficient, and there we denormalize data. We, instead of making too many joins, we basically created a single table having all the data. Okay, and this was very strange. So first half I spent in learning normalization. Second half of the year I spent learning denormalization. Okay, so so as of now we are not using to we as of now at this point, after fourth step, our database is not consistent, correct? Because we are using a caching layer. Second, we are not using the foreign key primary key anymore because we have denormalized database. Still, if your server is really useful, if your service is really useful, it'll rise in popularity, and this popularity, which should bring happiness to you, it actually swamps your server. Okay, now at this point, things are too slow. So the thumb rule that we follow is stop doing all kinds of server-side computation. Server-side computation as in the SQL query, if we are processing date, converting it into local time zone, or doing other magic on the server side querying, stop doing that. Let that be done by the caller. Maybe the browser should convert the date into the local format and represent, instead of us doing that. So all kinds of server-side computation we stop doing at this point. Okay, and still, if some queries will still be slow, so what we started doing is we periodically pre-materialize the most complex queries, meaning if you have a particular query coming in for many records. So what we do is we execute this query, keep the results prepared so that user can simply query this. Now, in this case, if you pre-materialize the data would become inconsistent because there are two copies of data. So every time you modify the base one, the data that you have pre-materialized would have to be updated. All right. And you stop joining them in most cases. All right. And at this point, reads would be okay, but writes would keep on getting slower because when you have a huge table and there are queries coming from all the things, so our tendency is to create triggers, create indexes. That's what we have learned as part of DBA. So we stop doing that. So that because every time you make a modification to a table, what happens is it updates the triggers, it calls the triggers and updates the other table, trigger updates the other tables. And similarly, when we make a modification to the table, indexes get updated, right? The data gets sorted again and indexes get updated. So at this point, we drop secondary indexes and triggers also. Now what you see is when earlier we stopped doing server-side computation, and we also stopped using triggers, the stored procedures, the secondary indexes, and the data is no longer consistent because we have perimeterized and done the caching. So in essence, we are not using the database functionalities at all. We are not utilizing the database functionalities for which Oracle is charging so high. And this is what happened at Amazon in 2005. Once their servers went down on Black Friday and they they could not cater to the users. They had a very bad day, and it was all over the newspapers that uh, Amazon was down. That very day there was a realization, and I think 2004 or 2000, in that year, I don't remember exactly year, that point of time it was decided to drop the entire database because we are not anyway using database functionality when we have reached this step number 7. Okay, so that point of time the NoSQL was designed. So all we need is a storage in which we can store key and the value. That's what was the conclusion at Amazon. And they came up with a very simplistic design of database. Okay, so this is where the NoSQL story starts. So why do we need NoSQL? To store humongous data, providing availability to many concurrent users, having an architecture in which more and more machines can be added as and when required. And these machines do not need to be enterprise grade. They can be a commodity hardware. Okay. So the most important part to understand about any NoSQL database is they are distributed in nature. They're distributed in nature, and they are to have for handling big data to cater to many users. Now when you have distributed, essentially our tables are going to get sliced into set of records, and distribute these slices are going to be distributed in the network. Okay, and when you have this kind of distributed system, every record need to be identifiable. Every row in the data need to be identifiable, and therefore there has to be an identification for every record. So most of the SQL databases, uh, all of the NoSQL databases are distributed in nature. There are around 150 databases available in the market that are that are NoSQL, and most of them are open source and have the same properties that we have discussed. So there are 4 general categories of NoSQL stores. First one is column oriented or wide column. We will discuss what does it mean by column oriented later, but they are very closer to storing data in the tables. Very similar to the classic one. HBase is column oriented. Then document oriented. Then document oriented meaning we store complex object as each row. Right now in our databases, whatever we have studied, every row is a simple flat array of values, right? Every row is a list of values, correct? That's how we have understood. But in case of document-oriented data stores, we have we keep every record as a complex object. Complex object meaning object means key and values, and complex object means values can be further another object. Okay, so for example, in the diagram, what you see is, let's say every record is a TV show. TV show contains many seasons, and every season contains episode. Every episode has a review, many reviews, and every episode has many cast members. So every record is a TV show, which is a complex object. Maybe JSON object, the way I was displaying to you, the JSON object representing tweet, in that kind of object will be represented as a record in MongoDB, CouchDB, MarkLogic, or ClusterPoint. All right. So that's document-oriented database. Document means complex object. Then key value pairs. This is the most primitive, and this is where the life of databases started. Okay, Dynamo, Amazon Dynamo is the first key value and first NoSQL created. Then MemCacheDB, though it's not really distributed in earlier it was not really distributed. Now it's very well distributed along with Redis and Voldemort. Okay, so the fourth one is kind of very new in the industry. When you have complex relationship to be stored, such as a graph, like me and you are friends, we have common friends and they have common friends. So at any point of time, if we want to compute things like who is more important in this graph of network, in this network of friends, or in this network of people, those kind of algorithms are to be run on these graph databases. Okay, so these are the four large criteria, categories of the NoSQL databases. All right, so the next is CAP theorem. Okay, CAP theorem is very important. Okay, so I mean, before we jump into CAP theorem, let's try to understand. NoSQL databases have a problem. The problem is that it can't really provide all the three things called consistency, availability, and partition tolerance. Okay, so, and there is a reason behind it. Theoretically, it is not possible. So one of the researchers called Eric Brewster came up with the CAP theorem, saying out of these three properties, none of the NoSQL in the world can provide all three. They can at most provide two out of these three properties. Consistency stands for all of the nodes, all of the computers that are serving as a database. As we have talked about, the NoSQL database is made up of many machines running simultaneously and giving output to the end user, right? So the user is the way when we talked about Zookeeper is kind of a NoSQL database, right? There are many machines trying to cater to the user. And again, in the Zookeeper also, we said clearly that the data is eventually consistent, not immediately consistent. Okay? So the reason for that is here. Okay, so as per this theorem, out of CAP, only two at a time is possible by any database. For example, consistency. All nodes need to see the same data at the same time. It should not be that you accessed another node and you got older data, while you access some other node, you got a newer data, right? That's consistency. Second is availability, a guarantee that every request receives a response about whether it was successful or failure. In case of availability, The more the availability, the better it is. Third is partition tolerance, meaning if some part of the network goes down, it should be able to tolerate it. So quickly, if you remember, in case of Zookeeper, if some part of the network goes down, will Zookeeper be fine? If one machine, two machine, or few machines go down, will Zookeeper run, or it will basically shut down completely? Yes? Did I put everyone to sleep? I think I have. It will do the election, correct, Kar? It will depend whether it's more than 50%, then shut down, right? Yes, so our Zookeeper is partition tolerant, right? Our Zookeeper is partition tolerant. So these are the three characteristic of NoSQL servers that basically define our system. Okay. All right. So what you see in the right diagram is kind of we have created like a set. Okay. So consistency and the partition, these two characteristics are catered by, I mean, HBase, MongoDB, Redis. They have, no, not actually. HBase is consistent and partition tolerant, but not highly available. RDBMS, relational databases, are consistent and highly available. Okay, consistent and available, but not really partition tolerant. Okay, so okay, so the picture says that there is nobody who is there as in the center, right? You see, there's no arrow that's pointing. There is no arrow that's pointing here. Okay, it overlaps, but there is no database. Here you see big table, hypertable, HBase, and so on. Here you see only a relational database. Here you see Dynamo, CouchDB, and so on. Actually, MongoDB and Zookeeper also lie here. Okay. All right. Now, a common question is, why is it so? Let's try to visualize. Let's try to visualize what happens in many kind of scenarios. In the first case, what you see is it's a relational database, right? There is a single machine is happily sitting there. All the users are reading, writing from the same machine. One user is modifying the same record, so the other users will be blocked from accessing it. So it's not really highly available. It's not really partition tolerant, because if this machine goes down, nobody will be able to access. That's our classic relational database. Then we have the second model where all the writers go to A while all the readers read from B, or both, A and B both. Readers could go to A and B both. Now in this case, since it will take some time for data to reach from A to B, meaning there is some time consumed in replication. Therefore, here the readers will receive data after a little bit time, and therefore it's not consistent, meaning if somebody wrote a data immediately and then another person or the same user tried to read the data and is reading from B, therefore it could say that I just wrote something new and I'm getting something else. There's something wrong. I'm still getting the older version. Therefore the data is not consistent, though it's eventually consistent because there is a single writer and eventually the data is going to reach to B in a right form. Okay, so there is this model. In this, there is no consistency, right? Though it's available and partition tolerant because many readers are able to read data parallelly from the cluster. Third model is Third model is the third model is the where we have the replication. Have you seen this model before? Anybody? The third model? Have we discussed any such system? We have one machine at which all the read writes are happening, and then there is a B machine at which we are keeping the backup. But the entire load is at A, not at B. So we talked about name node and secondary name node in the same way. Yes, Srini, thank you. Hang, thank you. Yes, so that's what it is. All right. So now is it clear to all that why it's not possible to have all three CAP? Because if we want to keep things available, we need multiple machines. And the moment we have multiple machines, data cannot be consistent. So to have partition tolerance and high availability, we need multiple machines. And when we have multiple machines, the communication between the servers would lead to inconsistency. All right. Next concept to understand before we jump into HBase is the orientedness in the database. Please pay attention. So it's very important to understand this part. All right. When we store a CSV file, in the location in our local file system, the data is stored first left to right, top to down, correct? First record gets stored, then second record gets stored, and so on, right? Like for example, here, if this is our CSV file, 10 will get stored, 10, Joe, 12, Mary, 11, Kathy. That's how the data will be physically saved, right? Is everybody with me? 10, comma, Joe, then new line, then 12, comma, Mary, then new line, then 11, comma, Kathy, then new line, right? That's how the data in CSV gets saved in the disk, correct? This is called row-oriented way of storing data. So far, all the databases, whether MySQL, Microsoft SQL, Oracle, they were all storing data physically in the files in a column, row-oriented manner, meaning first row gets stored in the disk, then second row, then third row. All right, this is called row-oriented way of storing data. It's basically a file format. How do you save data to the disk in the file? Because file is a sequence of bytes, while in memory we represent data as a complex object. All right. Next is, how do we save? How do we optimize this? So some researchers at Facebook and other places, they realized that if this data gets stored column wise, meaning let's store first column, okay, 10, 12, 11, and then store Joe, Mary, Kathy. If the data gets stored that way, it'll be it'll lead to better compression, because if same data is together, it's easier to compress, right? It's easier to compress, and that's what led to the development of a format for column-oriented way. So ORC is a column-oriented format, okay? meaning the data is stored in the manner like 10, 12, 11, then separated, then Joe, Mary, Kathy. 10, 12, 11, Joe, Mary, Kathy. Okay, these are just line number. 001, 002 are just line number, hidden IDs. Okay, everybody okay with this? All right. Now, so there was always this argument between various formats. Some said that no, for me, column oriented does not work out. For me, row oriented is better. Some said no, for me, column oriented works out better. So there was a constant battle that kept on going. So, so that's where HBase took a very smart stand and said that let me be a little political and I leave it to user whether they want to go for column oriented or row oriented or a hybrid of both. Okay, so this is called column family oriented database, meaning you group your columns into column family, right? You group your columns like here you have CF1, CF2, two column families, CF1 having employee ID and name as two columns under it, and CF2 is having a single column called age. Every column family gets stored in a row oriented manner, and column families are stored as first column family gets stored and then second. Okay, meaning so this column family will get stored first and then this, meaning 10 Joe, 12 Mary, 11 Kathy, and then 23, 33, 45. This is called column family oriented database. Okay, here the cleverness is that by cleverly designing, by smartly designing your column families, you can emulate either of the two or a hybrid structure. For example, you see this in one of the tables on the left hand side, we have one column family per column. Here you have three column families for all the three columns. Now here there is only one column family for all the columns. This is when this gets stored, this will be stored like 10, 12, 11, then Joe, Mary, Kathy, 23, 33, 45, while this will get stored as 10, Joe, 23, 12, Mary, 33, 11, Kathy, 45. Okay, why? Because all of this is a column family part, and inside column family, the data is stored in the row wise fashion. So this one is column oriented or row oriented. Quickly, who can answer this question? This one is column oriented or row oriented? Correct. It is column oriented, right? Because this will be saved in a column oriented manner. 10, 12, 11, Joe, Mary, Kathy. Why? Because column families are stored in that order. And this one is row oriented. Is it okay, George? All right, great. So this is column wise or column oriented. This is row oriented. So with the with the design of based on your design, you can actually emulate either of the two. All right. So we will talk about what does it mean by various how do you take advantage of these things when we discuss HBase. All right. So let's continue our discussion to HBase. A question from Mohsin. With column oriented data in primary key always is stored. I did not get it. With column oriented, right? The ordering is different. It's not stored separately. Ordering is different. Okay, meaning first column will be stored, then second column and third column. Okay, earlier data was stored in a row-wise manner, meaning first we stored all the data with a row and then second row and then third row, right? All right, so once we have covered the basics of NoSQL, let's continue our discussion on HBase. Okay, so this sheet might not be very interesting to you. Just be with me on this slide. We will go into more details of everything that we talk here. Okay, so HBase is column family oriented database, and it's consistent and partition tolerant. CP means consistent and partition tolerant, meaning it's not highly available. Okay, the design of HBase is based on the third paper of Google called Big Table. Google stored entire world's data in the Big Table. All the pages they crawled, they stored all of those pages and their metadata and their details in this big table. Okay, and HBase has been designed exactly on the big table. All right, so it's good for storing hundreds of millions or billions of rows, having hundreds and thousands of millions of columns. For HBase, columns and rows are same. Just like in a matrix, you can keep on adding as many rows and columns. Similarly, in case of HBase, you can keep on adding columns as well as rows. Both are same for HBase. All right. HBase has automated sharding. Those who are not aware about sharding, what does it mean by sharding? Sharding is slicing data on multiple servers. Earlier, before the down of our NoSQL databases, we used to divide the data on multiple nodes. At the time of, I'm talking about 2002, when there was no NoSQL, we used to actually use around 100 servers of Postgres, okay, and slice our data across these 100 servers at DESHA. Okay, this is a very rare known fact for lots of people that we use 100 databases at that time, slicing billions and hundreds of billions of record across these servers. Okay, so we used to do mostly manual sharding. Later on, we decided to write a wrapper so that the load distribution automatically happens on these databases. But still, the slicing of data was largely manual. Okay, and in case of HBase, that division of data is automated. The user just have to select appropriate keys and it will slice the data and put it in different machines. Automated reason server failure, meaning if one data store, one of the servers go down, there is another one to take care of it. HBase stores data in HDFS in its own proprietary format. Not proprietary, it's open source. It uses similar to ORC called RC file. Okay, similar to ORC as in case of Hive, it uses RC file. For processing, HBase does not provide a query language. That's the unfortunate part. While a competitor of HBase called Cassandra provides SQL engine called SQL. Here, if you have to process the data, you will have to write MapReduce. But engines like engines like Hive and Spark are able to run the queries on top of HBase. Okay, meaning converting those queries into MapReduce is those job of Spark or Hive. Now, HBase provides API, application programming interface, so that you can add data to it, retrieve data from it using an API, either using console or using a HTTP REST interface. Okay. So this API is available in Thrift. If something is available in Thrift, that means it is available in all kinds of programming language. The core API is available in Java, and it has got idea of coprocessors and Bloom filters. Coprocessors are like database triggers, and Bloom filters is a newer indexing mechanism on massive databases. All right. So here is the architecture of HBase. It has got these partitions, these portions that you see on the screen. It depends on HDFS and Zookeeper. Okay, this HBase contains this interface called API. This API can be called from console or Java program or any other language. This API, so here you have this box in which you have one master and many servers. Okay, classic design from Hadoop, single master, many machines. In the same way, you have one HBase master and many region servers. So we always first talk to master, then we go to the region server and read the data. Okay, region servers contain store the data in the form of H file, and it has got a small storage as well, and there is a write ahead in memory log. So this is what goes into every region server. Okay, so in another way, this is how you can visualize. There is a master and there are many region servers. Okay, and these region servers as well as master, they're all storing data in HDFS. User talks to the master and goes to region servers to read the data, and these master and region servers discover each other using Zookeeper. Okay, so master keeps the attendance, keeps track of which all region servers are alive using Zookeeper. All right, now something to understand about the data model. All right, so when we store a database table into HBase, or you can say HBase master, the tables are cut horizontally into regions. Each region comprises Each region comprises a subset of tables rows, and the region is denoted by table it belongs to, the first row and last row. Okay, now let me take a step back. A table is ordered by key. Table contains rows and rows contains row key. Okay, and table is cut into pieces called regions, and these regions are stored on the region servers. So table is automatically sharded and put on multiple regions, and region is denoted by which table it belongs to, first row and last row and first row key. Why? Because data is ordered by row key, right? If we know the first row key and last row key, we would know where is a particular key, right? If we are just keeping track of beginning and end of every section, we should be able to quickly jump to that section because we know the beginning and the end, right? Because the data is ordered. Initially, the table starts with a single region. Initially, the table starts with a single region, and as the data keeps on growing, the table keeps on getting splitted. Okay? As the as the As the data keeps on growing, it keeps on getting splitted. Make sense to you? No? All right. All right. So let me draw it for you quickly if I can do it. Okay, can you see my screen? All right. So imagine there is this nice master. Let's say he's a master. Good. And there are region server. This is one region server. There is another, and there is another region server. This is our region server. Okay. So these are our region servers. Good. So initially, let me change its color to say red or maybe black. All right. So initially, we'll be storing the data like this. This data contains kind of key, and then it also would have the columns in it. Okay, it would have columns in it like this. Similarly, there'll be more keys into this. Every key has a data in it. Okay, I think a better way to design it would be like this. Sounds good. This is another key, key 2. Okay, and key 1 and key 2 and so on. All right. So this is our initially there is on the table is loaded only on one machine. All right. Question from Kar, what problem is it solving in Hadoop ecosystem? Thank you. Why we need HBase is because, right, the the problem it's solving is when you have to modify the cells, when you have to modify the lot of structured data. Like, for example, can you modify the name of this person? As somebody was asking, how will update happen and how will this happen? So that kind of information, if you want to modify on a large scale, then HBase will be useful because Hive has just now started providing modifications and is not really yet ready for it. So HBase provides massive amount of updates on a large scale. ORC can achieve it, but that's just very new. Okay, it's not ready yet. All right, it's not highly available yet. Spark can't achieve that, Julie, because uh, okay, I did not get your name, J Liu. Okay, sorry for that. Yeah, so um, Spark is basically read-only engine to process. It does not provide any mechanism for storage or modification or storing any kind of data. It leaves that to the platform. Spark is largely for running programs or processing data. All right. So here, this is our table, and as it gets more and more records, okay, as it gets, can I copy this? As it gets more and more records, it'll be keep on becoming bigger. And the moment it becomes bigger, what would happen is this will break into two tables, to two sections. Okay, this will break into two sections, and this is where this will be moved to different machines. Of course, these keys will be unique. So while I'm trying here, it is key 1, okay, and key 3. All right. Also, these keys will be ordered. Now, similarly, as more and more data further grows in both the sides, let's say this one grows further and this one grows further, they will further break down into parts. They will further break down into parts. This will break into two parts, and then again distribution will happen. Okay? So this is called automated sharding. So initially there was one table, then like a fission reaction that breaks into two, and then again those individual parts start becoming bigger and they will break into two again, and that chain reaction will keep on happening. All right. Sometimes what happens is only one part keeps on becoming bigger, and that keeps on breaking into two. That way, we just have to change the criteria on which we are creating the data, the key, because this data is ordered by the key. So question from RS, what are the main applications where one would change the big data on priority? Let's say you are building kind of your large scale engine for gathering data from maybe internet, and you want to continuously update the previous values with the new values. Okay, in those cases HBase comes very handy. All right, so I hope this design is clear. So initially, a table comprises of single region. As the size of the region grows beyond a threshold, the table splits into two equal halves. Until the first split, the entire loading happens against single machine. As more and more splits occur, more and more regions occur, the loading gets distributed. Okay. So after a point of time, this is how it'll look like. Let's imagine that row keys are just alphabets. Okay. So it would look like this. Every region is represented by the range of keys. Just like on the top right of the dictionary, you have starting word and ending word, and that is sufficient for you to figure out whether your word exists on this page or some other, right? In the same way, every region is denoted by beginning and the ending key, and that's all right? And HBase master, this is the master. Master keeps a record of which range means which region, and which range is stored on which region server. Okay, so it just maintains these 1, 2, 3, 4, 5, 6 pointers with the range and the location of the servers, right? So this is how master and region servers work. Now let's understand what does it mean by data model, because this is most important. Yes, of course, the entire data is in HBase. When you create a table in HBase, it also creates in HDFS, and therefore there will be replica of entire thing that you're creating. Not only multiple region servers are available to cater to the same data, in case one region server is down, in case one of these region server goes down, these sections will be catered by some other region server because this data is available in HDFS. Okay, so it will be loaded again on another machine, and that another machine will start catering to this region as well. Okay, now the most important part for us is to understand the data model. Data model, I cannot make it more brief than these words. These words are from the paper of Google, uh, in which they have described big table as sparse, distributed, persistent, multidimensional sorted map. Okay, let's start from right to left. All right, every word is very important, and same is true with HBase, whatever is true for big table. So HBase data model means the way data is kept, the way data is kept in HBase. This is where most of the developers will be interacting with HBase. It's a map. Map means it is a key value pair. There is always a key. And it's a sorted map meaning the data is ordered by the key. Okay? Multidimensional means the value of this map could contain many values. Many value in the map could have multiple values. Okay? So key and values. All right? That's multidimensional. Persistent meaning whenever we make a change, okay? When we make a change in the data, it is saved in the disk. Distributed meaning this map, the so-called map, which has key and values, is divided and distributed in regions. And sparse means not all values are supposed to have the same set of fields. Okay, as we said, multi-dimension meaning value has multiple columns. Not all keys are supposed to have the same set of values. That means it's sparse. So you can imagine this to be a table in which first row has one column, while second row might have 100 columns, and third row might have 200 columns, and fourth row might have 1,000,000 columns. And HBase is completely okay with that. All right. So usually the way we study map is key and value, right? So we think about value as a single value. Here, the value is made up of multiple columns, and that's multidimensional. All right, huh? So Krishna's question is, MongoDB looks like similar to HBase. Okay, so I will just a little difference. In case of multidimensional, the MongoDB is having a complex object in the value. That's all is the difference. Okay. The other difference lies in the design. MongoDB's design is more like Zookeeper, which means it's not strongly consistent. It's eventually consistent. In case of HBase is strongly consistent. All right. A question from Srini, is it having same key name in replication data in different regions? Is it having same key name in replication data in different regions? No. A key is always once. So when I was telling that in case one region server goes down, the same keys, whatever was loaded by region server, because they are stored in the file, it'll be loaded by another region server 4 or maybe 3 or 2. Okay. But keys will be only available once on one of the region servers. HBase master keeps track of which keys are in which region. All right. In case one of the region server goes down, HBase master discovers it and then finds another region servers to cater for that. Did I make sense to you, Srini? Hang's question is, so each rows can have multiple column numbers. Yes, each rows can have multiple columns. Okay, different columns. Yes, key is like a primary key and it's used like that. Okay, so key is more like, row key is more like a primary key. Yes, Marcin, your understanding is correct. Okay, so row ID has column family, which is sorted by key value. Yes, you will understand more when we go ahead. All right. All right, good. Now, So this is the data model of HBase. So table is the basic unit of storage, and table HBase organizes data into tables. So generally for one project, we create a single table in HBase. And table names should be string that are safe for system path because it creates a folder per table. Then in the HDFS, then we have every table contains rows. The data is stored according to its row. Row is identified uniquely by a row key. Okay, row key is something which we need to provide. HBase would not assume anything. Okay, yes, Manu. It we will show you. I'll show you how to create each row with the different column names. Don't worry. All right, and row keys are not sequence number. Row keys are provided by us. And the amazing part about row key is you can keep any data in the row key. The first time I was designing a similar database in Cassandra in Moby, and to my surprise, the design that worked out for us was that we were storing entire binary data in the column name and some huge data in the row key. Okay, so row key is not really sequence numbers. Row key could be anything. It could be a 1 GB of movie file. Does that surprise you? So row key could be a huge music file or a movie file or a string or a name or a number. It could be anything. So the data is ordered by row key, and this ordering is bitwise. Okay, we generally have one project, one table for one project in HBase. Generally, yes. So that's part of design curve. We will have to come up with the row key, and it's up to the user. In case the same row key exists already, it will override the data. All right. Now, column family, as we have defined earlier, it's a data within a row is grouped by column family. Column family impacts the physical arrangement of the data. You must define upfront the way when we define a table, we create columns, right? We say this is my column, that is my column, right? In case of HBase, we have to define the column family upfront. Okay, we don't have to define the columns. We have to define the column families. Okay, they must be defined upfront and they're not easily modifiable, though HBase has provided and the online interface has provided the way to modify it. Okay, so every row in a table has same column family. A row need not store data in all of its families, and column families should be string. So table name and column family should be string because there will be a folder created for column family as well. Okay. Now, inside column family, we keep on adding columns. The way we keep on adding rows, the way we keep on adding rows, we keep on adding columns, right? And this is a deviation from what we have learned so far. Classically, we don't modify columns. We don't create new columns, right? In our relational databases, we don't create columns. But here, we do. So in the design, that's where we need to, twist our head a little bit in order to understand few things. One, we can keep on adding columns into column family as in when we wish to. Similarly, we can store humongous data inside the column name, the cell value, and the row key. Row key, column name, as well as the cell value, the actual place where we store data. okay? And the data that we can store is array, meaning binary data like blob. So in cell, a cell is identified by table name, row key, column family, column name, and something called version. To, to make the life easier for developers, it provides versioning of each cell. We don't define the number of columns in a column family. We just say that this is the column family. There is no limit on adding number of columns in a column family. And every row could have different number of columns in each column family. All right. So versions are classically based on the timestamp, but you can define your own version. And default number of versions that are kept are 3. So this is how you can think about HBase. So you have row key, column family, and you have 2 column families, personal and office, name and residence phone number, phone and address. This is how people from relational databases can think of a table. But in reality, the table is going to be very different. For this row, there could be 50 columns. For this row, there could be only 2 columns. Okay, so that's how. This is called a cell. These are called row keys, column families, column family, name, name, column name. All right. And structurally, this is how it is stored. This one is the row key. This one is the column family. This one is the column name. This one is the version, another version, and so on. Okay. Now, this is a very interesting example, and this is a classic example given by Bigtable as well. And this is for a very important use case. The reason why Hadoop was invented was to create a search engine. And they were not able to, the people who created Hadoop, we were trying to build this search engine. They could not come up with a data store in which such humongous data can be stored and processed. Okay, can be stored and processed. All right, and therefore the Bigtable or HBase was invented. So, and this is the reason. I mean, here it's called web table as per Google. They call it web table, and it's basically a humongous table containing the web pages of the world. Okay, we'll take this case of the data. A question from Krishna. So basically, whenever you save the data in every cell, okay, for every column and every row, when we save the data, the previous version is pushed into the history, and last 3 values are kept. You can modify that per column family. Okay. So just like so that you can undo the new change. All right. Now, here is the interesting aspect. So what they did was, in order to store the world's data, what they did was they created this nice table. Okay. In this table, the row key is the URL. This is the row key. This is the URL. Say com.google. Okay. This is the URL. Now, there was one column. There was one column containing the contents. Here was HTML content of the page. Okay, this is the page URL. Okay, so this is the page URL, this is the HTML content. Then they created another column in this. Okay, this column was very interesting. It was created for everybody who was referring to this page. Okay, say CloudX Lab is referring to google.com. So they created per referral one URL. So here, the let me just take a look. So CNNSI is referring to CNN.com like this. Okay, so let's say CloudX Lab is referring to to Google. So just to keep track of. Yes, that's right, Alvin. Okay, so here let me just focus on this example, this very important example. So com.google.com. So whenever they crawled a website, whenever when they wrote a crawler using their MapReduce, they crawled a website, parsed the content, and then updated this table. Found out who all google.com is linking. Let's say there was a website called um, let's say google.com is linking to maps.google.com. Okay, so it'll update here. It'll update here saying, it'll update here saying it's being referred, it's being referred by com.google.com as maps. Okay, similarly, com.google.com, when they downloaded the content of the com.google.com, they found out that it's linking to say something else, right? And let's say after a while, they downloaded the content of CloudX Lab, okay? CloudX Lab. And here is the HTML content of CloudX Lab, okay? So they stored this information about the CloudX Lab. So the idea here, what we're trying to do is we want to keep a track of who is referring to who. Okay, so the entire Google or the search engine works on the phenomena of page rank. That was the first criteria of creating a page rank, right? Creating the page rank was to basically find out who all are linking to our website. And to keep track of that, what they did was they maintained a huge table. And this table, they keep on adding more and more columns as they find out that CloudX Lab is referring to Hortonworks. They go to Hortonworks entry here, hortonworks.com. They go to Hortonworks entry and then mention that CloudX Lab is referring to you as HDP. Okay, so like that. So as and when more and more columns getting added, more and more rows will also get added into this. Similarly, let's go back to the example here. Let's take a case. So the first row key is www.cnn.com, which, and along with first column family called contents with the empty column name, which contains the HTML data of this page. Okay, this website, they found out after crawling other websites that CNNSI is referring to this website as CNN. And there's another website called mylook.ca is also referring to cnn.com as cnn.com. Okay, so as and when they are finding more and more websites referring to www.cnn.com, they're adding more and more columns into a column family called anchor. All right, and that's how the magic of this table begins. So if there are a million URL being referred by a million columns, there will be a table having a million rows and a million columns. Okay, as and when we find out that more people are referring to this, we add more columns into this table. Do I make sense to you? No? So on one hand, we are crawling the websites. On the other hand, we are trying to understand the content of crawled data. Crawling means downloading a website and saving the HTML content of that website. And after it saves the HTML, the crawler was saving the HTML content. It was basically trying to infer that who all it's pointing to. Yes? Hello? Okay. So George's question is under the cover, is this part of reasoning is that SDFS converts 4K block into 64 allowing blocks to be used? Yes, under the covers, it basically is using SDFS. So it might be using 64 or 128 MB. Yes. So basically, it makes it possible to utilize to basically add it a huge matrix of values. Did I make sense to you? Okay. So if you have a quick time, I can show you the H base. How does it look like before? Yeah. I hope nobody. You can give me 5 more minutes. So we can create a table. Let's say here I'm creating a table called let's say Jan 15. Okay. It has got, let's say, two column families called personal and official. Okay, good. You can create your own table as well. So here is my table. Okay, so right now, so you can see right now this is an empty table. Let's add a row. Now here we'll have to add some row key. Then we can add as many things as we want as long as they belong to a column family. So I could say personal and I could say random some data. Okay, and I could add more fields to personal, say email ID, and I could say official. Okay, and in official I can even leave the column name empty, and because column name empty is a valid column. So it's up to you, what do you want to write? Okay, you can see that. So we are able to add in the new row, we can add some other column family, and this time either we can choose the same column name or we could use some new column name. Okay, we could even say address. All right, so you can see that every row can contain different set of columns. If you use the same key again, it will overwrite the data. For same key and same column name, it will overwrite the data. When I say column name has two parts, column family name and the column name. You can see that. So let's say I say 1, 2, 3, 3, okay? And I'm saying add a field called official, and here this is new value. So it says that maximum versions must be positive, and basically it's an error. It says that, okay, so the UI is trying to catch some kind of error because we are trying to override the same data. Okay, so it has basically added one new column here because we gave a new column, while from the command line it basically overrides it. All right, good. So we are able to create our table from the UI. You can also try to do that, and if you want to use the console, you could use it by using the command. Okay, so here you could use hbase shell. All right, so same table called Jan15. Okay, we can say scan Jan15. We'll have to put double quotes around it. So you can see that it has printed the data. Okay, similarly, we could also say create table and follow these. Okay, so we could create I mean, we can see the status of HBase, see how many. So we could say status. It says 2 servers are up, 2 are dead. Okay, don't worry about it because I think those 2 that are dead are something which we have shut down. All right, and then we can say create the table and give the names of column family. Okay, create table name and give the names of column family. Then you can see the list of all the tables, and you can also use regular expressions to scan the list, and then you can put value into this table, this row, this column, and this value. Okay, so you can try these and then drop your table. Is there a SQL-like language for HBase to create and query the data? Unfortunately, no. But Hive and other systems like Spark let you query the data. Otherwise, you will have to write your own MapReduce. A question from RS. In RDBMS, one would have many tables as supplementary to main table. I see that. Each table is put up as column family in big table. It appears, yes. That's right. Please suggest also, it is generally okay to not have data in each supplementary table. So in case in the same big table. So yes. So the way we design is in case of here, joining the 2 tables will be hard. Therefore, what we do is whether it's MongoDB or HBase, we try to create a singular table containing the entire data that is required to be joined. Although it's very much possible to join the data by using MapReduce or third-party tools, but here, as I said, HBase is a huge map which is sorted and distributed. Okay, Mohsin's question is dynamically growing columns per row. Yes, that's right. That is CNN with 15 and 5 anchor and ABC with 2 anchor. Yes. All right. Where is my data? That's another question from us. The data is generally kept this place in the HDFS. Okay, so if you go into file browser, you should see a file for Jan15. So apps, HBase, data default. This is where the table is kept. You see, these are your tables and this one is my table. And this data you can see, this is the name of the column family, not column family. This is the region, ID of a region inside this table. Okay. If this table grows big, there'll be more and more such IDs and folders. Inside this, for both of my column families, we got one folder, official and personal. Okay, and official and personal. All right. So we could always say flush Jan15. Okay, so that the data from Jan15 get saved and persisted into here. Now you can see it is saved in HDFS. Earlier, it was in this temporary location. All right. So you can see that this is where your data for HDFS is. Row updates in case of HBase are atomic, no matter how many. Okay. Row columns constitute the row level transactions. This keeps the locking model very simple. Okay. Basically, the entire row, if you're editing in HBase, it can be atomic. All right. So, all right. So we'll continue from here in the next session. Next session, we'll quickly talk about Bloom filter. All right. And we'll talk in details about the rest of our discussion. All right. So see you next week at the same time. A quick question here as an assignment to all of you. It's a subjective question. Based on today's discussion, what you have to do is if you have to design an email system, massive email system like Gmail, what will be your column family? And as and when more and more emails are coming in, what will be your columns? And what will be your row ID and so on? It is up to you, what is it that you want to keep as a row, and what is it that you want to keep as a column, and what is it that you want to keep as column family. So you have to come up with the answers. Here is a subjective question to all of you. Okay, so you have to answer it here. All right, think about it. Think about all the things which we have talked about, that it's you can have as many rows as possible, as many columns as possible. Every row, the data is ordered by the row key, as well as you can have columns and cells. Okay, so think about it. You can keep anything in the column name, row key, and the cell. All right, thank you, Alvin. I'm very happy that you learned a lot, and I hope others also found the session informative. If you have any question, feel free to drop me an email. If you are lagging behind at any point, feel free to schedule a one-on-one session, and you just have to give me 3 different time slots so that I can pick one and be available and dedicate some time to you. All right, I will send you 2 emails, one with respect to the video of Tableau, and second with respect to the project if you want to group together. All right, so have a great week ahead. I look forward to see you next week and would love to answer your questions over the email. Okay, bye bye. Have a great week ahead. And bye, April, George, Krishna, Manu, Mohit, Nitesh, Ravi, Shamit, Pradeep, Rahela, Sunesh, Srini,
Huh?
RS, Teku.